Ever swiped a badge to get into a building? It feels so simple, doesn't it? Just a little beep and you're in. But behind that beep, there's a whole system making a split-second critical decision. And the single most important question that system has to answer is, what happens if the network goes down or the power goes out? Well, let's dive into the pretty ingenious way these systems are designed to keep working no matter what.
You know, in most IT systems, if the network fails, it's a pain. It's an inconvenience. Maybe a video feed drops or an email gets stuck. But in the world of access control, the stakes are so much higher.
I mean, just imagine this scenario for a second. The main server for a building crashes hard. Maybe the network switch in the IT closet literally starts smoking. So what happens now? Is everybody trapped inside? Or, even worse, are all the doors now unlocked, just waiting for anyone to walk right in? The answer to both of those has to be a hard no.
And that's because this stuff isn't just about keeping bad guys out. It's about life safety. People have to be able to get out during an emergency, while at the same time the building needs to stay secure. The whole system is basically designed from the ground up on one core principle. It can't ever truly fail.
So how in the world do they pull that off? Well, the solution is this really cool philosophy that, in short, gives the door its own brain. Let's break down exactly how this smart door idea actually works.
The official term for it is distributed intelligence. It's a fancy phrase for a really simple idea. Instead of having one giant central server making every single decision for every door, that decision-making power gets pushed out, to the edge, right to the individual controllers at each and every door.
So here's how it plays out. An admin adds you to the system on their computer. The second they hit save, the main server sends a little copy of that database down to the controller at the door, which stores it in its own local memory. That way, if the network dies later on, it just doesn't matter. The controller already has everything it needs. It just checks your badge against its local list and lets you in. It's so simple, but it's incredibly resilient.
Now, to make this whole distributed system work efficiently, the hardware is usually split into two different roles. You can think of it as the brains of the operation and then the muscle that does all the heavy lifting.
This setup works because of a really clear division of labor. First, you have the brain. That's the intelligent controller, and it's the master device. It's the one that connects to the network, holds that database we talked about, and makes the actual yes or no call. Then it sends a simple command over to the muscle, which is the interface module. This is a much simpler device. It's the slave. It has no brain, no database. It just takes orders from the controller to do the physical work.
So you might be asking, why bother splitting them up like this? Well, it all comes down to being efficient and saving a ton of money. You can put one of those expensive master brains in a single, secure IT room. Then you just run cheaper, simpler wiring out to a bunch of slave modules that you can place much closer to the doors they control. This totally cuts down on the amount of expensive network cable you have to run, which saves a fortune on parts and labor.
Okay, so we've got the brains and we've got the muscle. But how does this system actually interact with the physical world around it? Well, it does that through a set of ports that basically act like its senses. First off, it needs to hear you. The reader port is like the system's ear. It's just sitting there, constantly listening for that data to come in from the card reader the moment you swipe your badge.
Next, it needs to see what's going on. The input ports are its eyes. They're connected to sensors that tell it, hey, this door's physically open, or hey, someone just pushed the request to exit button.
And then you have the output port. You can think of this as the system's hands. After it makes a decision, it uses this port to actually do something in the real world, like sending power to unlock a door, blast a siren, or flash a strobe light. And there's one last special sense: touch. The tamper port is hooked up to a little switch inside the controller's metal box. If anyone tries to pry that box open without permission, the system feels it and immediately triggers an alarm.
All right, now that we get all the pieces, let's look at the two main ways you can actually put them all together. This is a huge design choice, and it's basically a decision between a traditional central hub and a newer all-in-one approach. Okay, so on one side you have the traditional panel-based setup. This is where all the wires for a door get pulled all the way back to a big metal box in a secure closet. Yeah, it's more expensive to install, but it's super secure. The other option is what's called an IP edge device. Here, the controller is built right into the reader on the wall, and while it's way cheaper and easier to install, that convenience, it comes with a major security risk.
Let's really focus on that risk, because this is a big one. The very thing that makes that IP edge reader so convenient and cheap is also its greatest weakness.
And this quote just says it all perfectly. That network cable, the one with a direct line into your entire corporate network, is sitting on the outside of the wall, in the insecure area. A hacker can literally just unscrew the reader from the wall, unplug your cable, and plug it right into their laptop. Just like that, boom, they're on your network. It's a physical backdoor.
So it all comes down to context, right? The key is using the right tool for the right job. For a low-security door inside like a supply closet, an IP edge reader is probably fine. But for a high-security main entrance on, say, a bank or a data center, no way. That's an unacceptable risk, and you'd always go with the more secure, panel-based design.
So the next time you swipe your card, take a second to remember that hidden intelligence humming away inside the wall, a tiny computer designed to work even when everything else has completely failed. It really makes you wonder, doesn't it? Where else in our lives are these invisible security trade-offs hiding right in plain sight?